Hello, in this math video, I will do a GED math video regarding probability. So, go ahead and get out your notebook because there are some terms and formulas we got to go over. So, yeah. Okay, so the first thing I want to talk about is what is probability. So, you've probably seen this before. Hold on. So, yeah, let's talk about probability or the typical probability formula. So, okay, so you probably seen it, heard of it. It's basically a fraction, and on the t top, it's the number of favorable outcomes. And then on the bottom, it's the total. Okay, so let me go show you a simple example. So, for example, what is the probability of getting one out of choosing one out of it when you roll one dice? So, um, in a dice, there's how many faces are there in a dice? I think there's six, right? And then how many ones are there in a dice? One. So you put one on the top, and then your total possibility is on the bottom. Okay. So that's pretty simple. Sometimes there will be more like mutually exclusive events, multiple events, and so there's other formulas we have to talk about regarding probability. So the second formula I want to go over is the mutually exclusive events. Basically, mutually exclusive events are events that occur at the same time, but there is a keyword. So that you would use this formula if you ever hear the word or. Okay, so yeah, or means mutually exclusive. So mutually, so it would be P of A or B. So the keyword, so for mutually exclusive, you're going to use this formula P of A plus P of B. Okay. And then the keyword is or. So whenever you hear the word or in a probability word problem, that's how you know you're going to use this formula P of A plus P of B. Okay. I'm gonna clear. There's other formulas we got to talk about. So if you need to pause the video to write these formulas down, go ahead. But I am going to clear right now. Okay, so the third formula we have to talk about is probability of multiple events, independent for independent events. Basically, events not affected by each other. The probability of all events happening is the product of their individual probability, and the key word is and or both. So if you ever hear the word and or both in a probability word problem, you're going to use this formula. So, okay. So yeah, so the keyword is, let me write this down. Keyword is and or both. Okay, so if you ever hear that keyword and or both on a probability word problem, you know you're going to multiply to equate P of A times P of B. Okay, and then the last one, go ahead and pause the video if you need to write this formula down, but I'm going to pause. I'm going to clear and go over the fourth one. So the fourth formula is probability of complementary events. A complementary event refers to events where if one thing happens, it implies something else happens. The probability of complementary events will be equal to 1 over PA. So let me write this down. Okay, so yeah, the fourth one is this one, probability of complementary events. A complementary event refers to an event where if one thing happens, it implies something else happens, and you will use the formula 1 minus p of a squared. Okay, so if you got all the formulas down, we're going to do the three questions. So I'm going to clear and I'm going to start with question one. So question one says, in a deck of playing cards, what is the probability of drawing either a heart or a spade? So this one, you're going to use the first formula. Yeah, yeah, don't be fooled. It's the first formula. Um, so it's going to be probability equals number of favor outcomes over the total number of possible outcomes. Okay, so on the top, what is our favorable outcome? It's the number of hearts plus number of spades. You know what? You could also have used you see the keyword or, you could have also used yeah, you could have also used P of A. I think this P of A, P of B, right? So what is the probability of a heart? Um, I believe there is 12 hearts in a deck of cards, right? So how many are how many total are in a deck of card 52? And then there's 12 hearts, right? And then plus how about the number of spades? I'm not even sure. Let me see. I think it's 12 as well. Hold on, let me figure this out. Yeah, I don't really play much cards, so I don't really know how many hearts, but I can check it out. I think you could use this formulas. I think we should use this formula because do you see the word or? So that's a big clue you'll use this formula, but let me double check how many hearts in a deck of cards. Right, I was wrong. There is 13 hearts in a deck of card. And if it, yeah, so I'm going to do 1352 for the P of A. And then for the P of B, I think there's also 13. What's the other one? Spade. There's also 13 out of 52. So put it all together. What's 1352 plus 1352? That would be 26. And then on the bottom, your LCD is 52, so the bottom stays the same. And then this could be reduced by 26. So what's 26 divided by 26? 1. What's 52 divided by 26? 2. So your total probability is 1/2. So yeah, you could have forget about this formula. I hear the word or. right, you're going to use this formula, P of A plus P of B. Okay, so go ahead and write that down while I do the next one. Okay, so the correct answer is 1/2. Okay, question two. What is the probability of getting heads in a coin flip and rolling a four on the die, both in two consecutive events? Okay. So when they say consecutive events, you know you're going to use the formula three, right? Probability of multiple events. So you're going to multiply P of A times P of B. So yeah, you're going to do P of A times P of B, right? And let's see, what is the probability of getting heads in a coin flip? So a coin has only two sides, right? And rolling, so let's do the first one, P of A. What is the probability of getting heads in a coin flip? So that's only 50% or 1/2, right? Right. A coin has two faces, heads or tails. Um, right. There's a 51 out of 2 chance of getting heads. And then we're gonna times it by P of B. And then what is the probability of rolling four on the die? So, what is a die? A dice has six faces, right? And then how many fours do you have in a dice? One, right? In a dice, you have one, two, three, four, five, six. There's only one possibility of getting four. So you're going to put one on the top, and then you're going to multiply because it is because we are dealing with multiple events, you do multiply these two events. So 1/2 times 1/6 is 1/12. So that is D. Okay, so it's all about knowing your formulas. Let's do the last one. Let's see, question three. So in a game, a player has a 1/5 chance of winning a prize. If he plays the game four times, what is the probability that he will win the prize at least once? So this is the last formula we talked about, the probability of complementary events. So if you're going to use probability of complementary events, you're going to do 1 minus P of A. So it's going to be 1. And then what's the probability P of A? So basically, it's the probability of not winning the prize in a single attempt. So if a player has 1/5 chance of winning a prize, so I think the P of A is 1/5, right? Uh, in in a game, the player has 1/5 a chance of winning the prize. So it's going to be 1/5. And then if you simplify, what is 1 minus 1/5? 4/5, right? 1 minus 1/5, or you can remember when you're subtracting or adding fraction, you need a common denominator. So you can rewrite 1 as 5/5, which becomes 4/5. So this 4/5 is the probability of not winning the prize in a single attempt. But that is not our answer. So probability, So since the player is playing the game four times independently, so it says he's playing the game four times independently, the probability of not winning the prize in any attempt will be 4/5 times raised to the fourth, which is 256 minus 625. So then you have to go back to this formula. So it's gonna be 1 minus this 256 over 625. And when you simplify that, that's 369 over 625, right? Because 1 could be written as 625 over 625. So that is B. So this one's a little bit tricky. First you had to figure out the probability of not winning, which is 1 minus 1/5. And then because he played it four times, you raise 4/5 to the power 4, and you get 256 over 625. And then you reuse this formula, so it's 1 minus 256 over 625, and that's how I got 369 over 625. Let's check the work. Perfect. Okay, so this was a small introduction of probability. So if you wrote down those formulas, you should be good to go. Okay, I'm going to stop here.